Hello, this is video 3-2 on rotational energy. I will be doing problem number 15. So here we go. A mass 1, 14.5 kilogram object and a mass 2, 12 kilogram object are suspended, joined by a cord that passes over a pulley with a radius of 10 centimeters and a mass of 3 kilograms. See figure below, obviously, right here. The cord has a negligible mass and does not slip on the pulley. The pulley rotates on its axis without friction, and the object starts from rest 3 meters apart. Treating the pulley as a uniform disk determines speeds of the two objects as they pass each other. So I wrote down here A, list givens, mass 1, mass 2, and then some attributes of the pulley. Its radius is 0.1 meters, mass is 3 kilograms, and this will probably come in handy later, so I figured we'll write down that the disks, because it's a disk, this is a disk shape. Its moment of inertia is 1/2 mr squared. And then, so we're going to be using energy here because this is the energy video. No, it's because we're going to be observing this, what would I call this? The system at 2 points, which is this initial point, and then the point where these masses would the point where these masses would meet and be at the same level. And this isn't collisions, so no need to use momentum. That's probably video 3-3. So, okay, we got our givens. We are going to use energy, so I decided to label a point of reference. This will come in handy later. And here's just a little mock LOL diagram I wrote just to get ahead of myself. I did do a much more academic one, and we can talk about that at the end. So this is just a little scratch up one. So obviously at this initial point, we have M1 with gravitational energy. It's got a whole lot of it. System, pulley, two objects, Earth. And then at the end, here, why don't I draw this out? So at the end of the motion, the second point we're going to be observing, we're going to have this M1 move down, this M2 move up, and they are going to be at the same point. So that's kind of the point I'm observing. Figured I'd draw it out, make it a little easier. So that's gone. So we still have potential energy in the mass 1. We now have potential energy in mass 2. We know the system moving, so we have some kinetic in 1, kinetic in 2. It's very important that we put the wheel in there, the pulley in there, because the pulley is going to be dissipating energy as well. Because there is friction on the pulley. If they said no friction on the pulley, well, then we wouldn't worry about that at all. Also, a little side note, no reason to include the pulley's gravitational energy because the pulley is not moving up or down, it's staying at this one point. Yes, it is rotating, but vertical displacement is 0. Okay, so now we can make a equation of that. Gravitational energy mass 1, and then we have initial, and then final, this is mass 1, gravitational plus kinetic, mass 2, gravitational plus kinetic, and then the rotational energy. So we're going to go ahead and sub in these formulas, I suppose. So we know k equals 1/2 mv squared, k rotational equals 1/2 moment of inertia, radial speed, angular speed, angular velocity squared, and then gravitational energy h. Go ahead and put that in. Some important things to note. That this final height of both mass 1 and mass 2 is the same because they're going to be meeting at the same point. Yes, mass 1 travels down, mass 2 travels up, but anyways, it is the same point. And then the speeds are also going to be the same because the objects are attached. And then, also the the question only asks for one speed, so if you had any doubt about that for whatever reason, you could just take a look at the question. So we go on, we plug all this in, and now we plug in our values. Just a side note, I did some manipulating with the rotational energy first, so I subbed in a V over R for omega, and then I simplified. I eliminated the radiuses. So then we have 1/2 mv squared, and then I plugged in for m down here. So yes, just I'll quickly go over this. I plugged in G for everything that needed G, which is all our gravitational energy. Plugged in, the mass of each respective object in the system. Plugged in the heights where I needed to, and then the only variable that we need to solve for is v squared. So this next part, some simplifying, even more simplifying, and I isolated variable v squared. Oh, that should just be a v. Thank you. So yeah, you divide by this on both sides, and then you take the square root, and then you're left with the speed equals 1.5 meters squared. Or meters per second, not meters squared. I apologize. And I did not end up doing this before the due date, but WebSign did give us an answer of 1.62 meters per second. This is within 10% of our answer, so we are all good. And then some takeaways. Let's revisit that LOL diagram. I just wrote these numbers don't mean anything, but I guess they do have a relation to one another. So obviously all the initial energy in the system is with gravitational mass 1. And at the end, we can actually see that, let me try to think. So the horizontal distance, the horizontal displacement above the ground for mass 1, it's just cut in half. It's just cut in half. It's the point in between 3 and 0. So then the energy in the gravitational energy in mass 1 at the end is just half of what it initially started with. And then the rest of these numbers, they're not that important, but they should just show you that M2 greater than KM1, greater than KM2, greater than K rotational. K rotational is definitely the smallest in the system. So that should, let me look at my takeaways again. Sorry. So something I wanted to accomplish with this is kind of, Mr. Lesher, he's been grading my my videos, and I can see that you wanted my graphs and diagrams with grids. So here's what I did there with the LOL diagrams. So hopefully that's all good. And then one of them, you wanted me to explain why we can use like kinematics. And I know that's not really the same with like energy, or like the same thing you're trying to get across, but I did explain why we need to use energy. I feel like for any additional takeaways, it's a pretty simple problem. Just, LOL is king. We all know that. It's very useful. So that's about it, and thank you.